This video is going to run through how to solve this very first problem on these practice problems. It is very similar to the lab we just did with the sodium hydroxide and sulfuric acid. So that's going to be kind of the references that I make to this. So step one in this unit, and for the test, I would divide my workspace in half immediately and label one side with the solution information and then one side with the reaction information. In these experiments, it's my solution that is changing temperature. So it's my solution that is being affected by a reaction that's causing the solution either to gain energy and change its temp or lose energy and change its temp, okay? So in order to get to my final answer, right, my final answer being what is my heat of reaction, which is a kilojoule per mole relationship, I need to have a number of kilojoules, I need to have a number of moles. From my solution, I can get my amount of kilojoules the reaction either gave off or took in, because however much the water did, the reaction did the opposite. So for the solution, I'm going to set up an MC delta T, temperature initial and temperature final. This C is given to me since it's a solution. The temperature initial is in the data table. My temperature final is in the data table. Problem is masses in grams, and in this particular situation, the solution that's given to me is given in volume, but I also have a density given. So with the density, I can always get mass because volume times density is what mass is. So if you multiply those two things together, you will get a mass for the solution of 171 grams. Oh my God, sorry. Okay, so we MC delta T that, you're gonna get a Q equal to negative 8794.53. And every time you MC delta T, Q comes out in joules. Now here is the large leap that you have to make every time you do these problems. When you calculate an energy that the solution either gained or lost, the assumption is then that is the amount of energy either gained or lost by the reaction, which means it's an opposite sign. So in this problem, my water gained 8,794 joules, which means my reaction, sorry, I said that wrong. My water lost 8,794 joules with that negative sign, means my reaction gained it, okay? So from that, I can get a kilojoule amount up here if I divide by 1,000. So my kilojoules for this reaction is 8.794, etc., more digits, okay? So I got that from the solution. The amount of energy either gained or lost by the solution equals the amount of energy either gained or lost by the reaction. In this case, my solution gave it off, so my reaction took it in. To finish solving for heat of reaction then, what I need here is to get a mole reaction. In order to get a mole reaction, I need to take something from my reaction and convert it into mole. Your reaction was hydrochloric reaction with calcium. On the test, I promise that I will tell you what your limiting reactant is. In this case, problem's actually set up where either one you choose would work, but I'm gonna use hydrochloric just because I want to. But you could choose either in this problem. So I'm gonna start with my 51.2 mils of hydrochloric, knowing that in the end, what I'm trying to get to is my mole reaction. Oh my God, you guys. So I can go from mils to liters using the memorized conversion of 1,000 mils to 1. And then I can go from liters to moles when I have a solution. So in this problem, my solution, I have a 3 molar hydrochloric solution right there. So my relationship is 3 moles for every 1 liter. That got me to moles of hydrochloric. So my last step is I want to go, cannot do this, from, seriously, you guys. I want to go from moles of hydrochloric into mole reaction. And every time we do that, it's the coefficient per one reaction. From that, that's going to give me my mole reaction number. So if you do that calculation all the way through, you will find that your mole number is 0.0768. From that, then, you can divide your amount of kilojoules by your amount of moles to get a heat of reaction, which is 114 kilojoule per mole of my reaction. So the flow here again, and I wrote this flow on the last page, but if you need a little something to help you, the flow for these problems is step 1, get the Q from water or from the solution. So you're gonna wanna make sure you're using the solution information. Number 2, flip your Q sign and make a kilojoule. Number 3, you need to get 2 mole reaction from your limiting reactant. And again, I will tell you what your limiting reactant is on the test, I promise. But in this one, you can use either. They both work. And then your very last step, once you've done that, is to take your kilojoule amount and divide it by your mole reaction, and that gets you your final answer. Keep trying these other problems and make sure to finish the labs as well.